record. Okay, so as you can see, I did not show a plan because basically the plan is easy. One, we discussed the previous lab, which is lab 3. 2, we continue with our work. So how about we start discussing your questions? I got a lot of questions through email and through text messaging. Oh my God, this is thunder. Weird. Yeah, so how about we tackle your questions? Some of the questions I could answer and some of the questions I couldn't answer. Yes, Imad, do you want to start?
Yes, doctor. First of all, doctor, بس أول سؤال بس هو بخصوص أنت في gave us the period now في time ناخد uncertainty هون أو لا doctor؟
Okay. سمعت بس آخر سؤال. Are you talking about this table where you have radius period and t squared? So everybody was not happy with Imad's voice. I thought I was the only one. Anyway, I think Imad has a question. And Imad's question is, in the table of measurements, do I add uncertainties, right, Imad?
لا دكتور هو أنا my question specifically هو بخصوص تبع t squared uncertainty.
Okay. If I go back to the results, is there any plus or minus in the table?
No.
No need for uncertainties. Listen, I'm going to be very clear with you. Do the uncertainties only if they ask you to. If they don't ask you to and you still want to do the uncertainties, yes, you can. Didn't I give you the time using a digital measuring tool, right? So you can tell the uncertainty on t, and then how do you calculate the period?
It's t out of 10.
Okay, so it's t divided by 10, so it's a function. You do propagation of error to find the period, the uncertainty on the period. And then how do you find t squared? By simply doing t times t or t to the power 2. So you do the uncertainty on that, the propagation of error on that to find the uncertainty on t squared. If you want to do this, yes, you are most welcome to do it. However, I don't see why you should do it if they don't ask you to do it. Because eventually they want you to plot and they want you to find the slope and the error on the slope, which means the uncertainty on your x and y will be your error bars, and we're not taking error bars in our error on the slope, you see? So we will not gonna use them. If you want, you can skip the question.
اوكي دكتور ما انا سألتك دكتور لانه يعني اذا انا باخذ for example uncertainty على t squared انه الفاليوز تاعت الثانية حسيت انه حيفرقوا فهلا فهمت مش رح اخذ uncertainties على t squared والسؤال الثاني هو بس بخصوص question 7 هلا دكتور question 7 انا توصلت لايكويشن ولقيت انه relation انا انت بدك اياني مثل انه يعني انه اشرح على طريقة equation او اشرح انه more انه theoretical الخبرية.
Theoretical, I mean conceptual understanding and equation, for me it's the same idea.
Okay.
You see, yeah, with the equation would help you. Mathematically, things are always easier. Okay?
Yes.
All right. Priscilla, and which question are you talking about? Nice question. You're talking about Imad's question? All right. Anyway, do you have any issues related to this? Let me see. Somebody asked me about if we take meters and centimeters. You were worried with meters and centimeters, or am I wrong? Was it you, Imad, who asked me about meters and centimeters? Somebody told me probably on the chat that E, which is the deviation, is going so small that it's really, the calculator is giving you 0.
Yes, أنا دكتور.
Yeah. So.
Yes, Excel عم بحط ليها 0 بعرف.
Okay, listen, I have the answer for you. I didn't want to discuss this through the chat because I want to make sure I'm clear. Excel does not take a lot of decimals. So if you're dealing with very big units, Excel may round the thing for you, and you want to avoid this. For example, if you say in meters, I don't know, the thickness of this pen is 0.5 centimeter. So in meters, you have to divide by 100. So we end up with a lot of decimals. At some point, Excel will round it for you, will truncate the values, and it will be hiding some information from you. If I were you, I keep things as is, like in centimeters, but be careful because sometimes you have to mix units, and you're not allowed to use centimeters with newtons, for example, or with grams and all this, you know. So try to use centimeters until you have no choice but to convert. Okay, so I think this E going to 0 is because of Excel not allowing you to use a lot of decimals. Okay.
يعني دكتور أنا بس هيك small question، يعني أنا فيني الجراف
كل
شيء السلوب وخبار على السنتيمتر، بس إنه تحت يعني مشان centripetal force إنه بدي ألاقيها إنه تحول لمترز وبيشتغل.
Listen, I'll tell you what I do. I plot radius centimeter time in seconds, or t squared in second squared. I find the slope. The unit of the slope is the unit of y over the unit of x. I can see that the radius is the y and t squared. So the unit for the slope is going to be centimeter per second squared. Then you convert your slope to do any other calculation. So as plot and slope and error on the slope, keep it centimeters, then convert to be able to find the centripetal force or the hanging mass or whatever they ask you to. Okay?
Yes, that's أنا هيك عملت بالصراحة.
All right, I want to check the chat. Somebody has his hand up. I don't think so. Probably I cannot see it. All right, if you have your hand up, please speak up. All right, is it okay to share my screen when we're done with the session? I have a question about number 4. Noha, do you want to do this now or at the end of the session?
Doctor?
Yes, Jane.
I was the one who raised my hand.
Yes, go ahead, Jane.
Doctor, I just wanted to ask you, Anna, I got a very high percent error, and it was around 80%. But I just want to ask you, does it have to do something with the results or the way that I'm working?
Listen, I did not try recently to do the calculation myself. I know for a fact that the percentage difference would mean two things. One, you have a calculation mistake. Two, probably the results I gave you are wrong for a reason. And it's also possible. How about we try to see if you have a calculation mistake?
Yeah, sure.
Okay.
Do you want me to share?
Can we do this later? Probably after class, or probably you want to send me your results as a picture on WhatsApp and I go through them?
Yeah, but in the chat, like all the others who are working with the same results are stating
many students
they also have very high.
All right, so most probably there's something wrong with the results, which is good anyway. It means you did not do any mistake. Probably I have some given that is different than the given I gave you. Could it be that I've been giving you the time for less than 10 oscillations? Let me check. So far, keep it as is and let me check it myself. So don't share your answers with me. Let me check. All right, can you tell me which result, number 1 or 2, so I can check it?
Number two.
So apparently there's something wrong with results number 2. Okay, I will check again and see. I'll do the calculations. Probably, as I told you, the time measured was not for 10 oscillations.
Yeah, probably. And I divided it by 10.
Yes.
That's why. Okay,
yeah, I'm going to check again. I can't remember when I got the results from. Okay, Jane. Noha said she wants to share her screen.
Yes.
Do you want to do it now?
Or as you wish.
Okay.
It's okay.
Okay, let's do it now. Probably your friends would want to see your question. Go ahead, Noha.
Okay, can you see my screen?
Yes, I can.
Okay, to find the error on the slope, I watched the video that you were explaining. So I got the sum, the error, the error to be 0.03. But when I put it under the radical so I can get the error, I got 0.18, which does not work. In this case, we wouldn't have an error on the slope.
Okay,
so I just wanted to ask what I did wrong.
Okay, so you found, so the slope is 0.18 and the uncertainty is radical of 0.03.
Yes.
Okay, radical of 0.03183, which means that the error is bigger or at least equal to the slope, and you believe there's something wrong. So how did you find the error? You added all the e squared?
Yes, I found the sum of e squared, and then I applied the formula.
You divided by delta and then n over n minus 2?
Yes.
Okay. All right. So, but I can see from your graph that you have a very nice line. So there is a calculation mistake somewhere. And the calculation mistake, can you share this with me so I can go over it? Can you send me an email with the Excel sheet?
Yes, of course, I'll do it now.
Yes,
Thank you.
yes, because I see the results are nice. Yeah. And somebody's telling you, and I believe in that too, if you want to stop sharing and save the file, send it to me by email. I want to find your mistake. A lot of students are telling you, and this is also my comment, try the Linus method. It's so much easier to use. I know that now for physics 302, we don't advise a lot of Linus method because we don't want to confuse you. But eventually, the Linus method is so much easier to use. Okay, but how about we find your mistake now for you to understand what you're doing, and then we switch to the Linus method. All right.
Yes, I tried the Linus method and it worked, but I just wanted to know what I did wrong.
Yes,
that's all.
You have the right to do so. Okay, people, I lost track of the chat. Let me go back to Noha's comment. Oh, that's a lot. Okay. All right. Anyway, I used the Linus method to find the slope and the error on the slope. Of course, you can do that, Fadi. All right, for the 80%, I got the idea. It was result number 2. Use pi squared. Where do we use? Yeah, so pi squared, I don't know what's about it, but yes, there's some pi squared in the equation. The 3 slope, how many decimals do we take after the decimals? All right, for the slope, you look at the error on the slope. Look at the error on the slope. If the error on the slope is 1 decimal, round your slope to 1 decimal. If the error on the slope is 2 decimals, round the slope to 2 decimals, okay? Now, concerning the y-intercept, ignore it because the y-intercept is supposedly 0 or very close to 0. Otherwise, you have to find the uncertainty on the y-intercept and do the rounding, but I don't want you to go there, just for you to decrease the time wasted on this. Yes, I advise everybody to try the Linus method. I'm not in a hurry though. We can do that after the midterm, as long as you know what you're doing. John, what do you mean your Excel sheet is so empty because of the Linus method? All right, let's discuss number 7. The weight of the hanging mass over the pulley is kept constant. If you were to double its value while keeping the radius constant, what would happen to the value of the period? All right, I need you to remember, John, that you had the central post, and this is another post where you had your actual mass, and your actual mass was hanging through a pulley to a hanging mass, okay? To mimic a certain centripetal force, okay? If you add this, like you double the mass, it's as if you double the centripetal force. They said radius constant, I suppose yes, which means you need a bigger speed of rotation to have the same equivalent centripetal force. So instead of making your platform go in a circle at a low speed, you need higher speed to be equivalent to this weight. Because you know, high speed will give you centripetal force or a behavior very similar to where you have a hanging mass of a certain Newton number of magnitude, you know? So I would say the speed squared must be doubled. So if the mass is doubled, the force is doubled. So speed squared is doubled. So speed will be multiplied by radical 2. Now try to discuss what would happen to the period. John, do you know the relationship between period and speed? Yes, John. All right. So now try, we discussed mass doubled, force doubled, speed squared doubled. Continue to discuss what would happen to the period. Okay, I love this question. This is a new question. All right, write it down in a definitely. Write it down in a paragraph. It would help to give what you believe would happen. All right, this is a nice lab because I think, is it the first lab where you do a plot and linear regression and the error on the slope? And since you did not take any physics lab previously, let's take this lab to to be like your first experience in tackling those. I'm trying to guess for the next lab, you will have to do this again. So, which means these are your only chance to practice before the midterm, right? Now let's see what with Fadi. So we double the mass hanging from the pulley, not the one, yes, the one hanging, the weight of the hanging mass. A lot of students will have difficulties seeing the difference between the hanging mass and the system. Mass of the hanging object, mass hanging over the pulley. All right, so this is your system, okay? And this is over the pulley. Let's not talking hanging, let's not call it hanging object, let's call it system. What was the mass given to you, hanging? 105, is it the same for result 1 and result 2? Okay, so apparently, yeah, it's a bit different. All right, so yes, they want you to do that, Fadi. This is exactly the question. They want you to see what happens to the period. Look, the weight over the pulley, like the hanging weight, is kept constant. If we were to double, so this is what we did in the experiment. Now there's an if statement. If we were to double its value while keeping radius constant, what would happen to the period? To exactly the same on your system. Yeah, all right. Okay. Any other question related to this lab? Lab number 3. By the way, we're flying. We're done with lab number 3. It's not the same for other sections. Yes.
أنا عندي سؤال هو مخصص باللاب، بس هيك إنه بالمترم حيجينا مثل أجراف ونرسم ونحلل أو كيف بس؟
Listen, Naimad, I need to answer a lot of questions related to the midterm. And the question number 1 would be, when is the midterm? So on my checklist for tonight, I need to think of a date and a schedule coming up until the midterm, and I need to share it with you as soon as possible. My only worry is that our Tuesday section is a bit behind, so يمكن نضطر ننطرهم a week or something. This is one thing. Another thing, we need to decide how will the midterm happen. But so far, I can tell you something. The midterm would be multiple choice. It would be also something for you to plot, something for you to analyze. So hopefully it will have a multiple choice question and a subjective part. Okay, for the multiple choice part, I can also give you values, and the question would be, what is the slope, A, B, C, D? Or the question would be, what is the slope and the error on it, A, B, C, D, to pick from. And this is easy for you because you can cross out the answers that are wrong, and sometimes you can guess the answer without doing the calculation. Sometimes an answer is not rounded well. Sometimes an error is not one significant figure. So in most of those questions, you don't have to do the Linus method and many other things. I can give you values to find the average and the RMS, you know. So the multiple choice questions will be broken down. Instead of you having a problem, you will have 10 questions broken down separately. And I don't like this. But sometimes we may have to do this. But all in all, I will have to tell you before the exam. I need to confirm how the midterm is going to be because I don't want you to be surprised. Okay? Give me a week, Imad, to be able to answer everything related to midterm. The time, the date, everything. Okay? I have a feeling it's going to be on Saturday because I need to give a good schedule for everybody, all the sections, and I think we are 6 sections, and there's no way to find a common time. But if we do it on Saturday, do you mind? Everyone in this room, do you mind? Saturday?
No problem.
بس بالويك تبع الميد تيرم اللي انت حاطيه بيكون عندنا فيزيكس بيكون عندنا فيزيكس exam Saturday.
Okay, let's see. This is the schedule. It says that it has to be 1922. So any time between 15 and 26. When is your physics test date?
27.
27. So you want it to be far from 27. Probably it's gonna be 20. How do you feel if it's on the 20th?
بحس منيح.
20 ما عنا شيء.
Yeah, Eddie, what do you mean by Saturdays are booked? You mean booked? All right. What do you mean by booked? You have a test on that day?
Yes, doctor, they come to 04 lab.
Okay. When is it? Morning or afternoon?
No idea الصراحة.
Isn't oh, okay, we're talking March. March 16 is a Sunday. So or am I wrong? No, March 16 is a Tuesday. Okay, let me open my calendar. I really need to talk to you about this because it will be difficult for me to guess later on. So 16 is a Tuesday, March 16. So I was thinking about March 20, and March 20 is a Saturday. Anyway, I will let you know. We can pick Monday, we can pick, I don't know, I mean morning, we can pick evening, but it is a Saturday.
دكتور Saturday أحسن. Saturday 20 بيكون كتير بعيد عن باقي مثلا chemistry lab عنا أيام Monday 15. إذا عملتي Tuesday 16 رح نلحق ندرس بعد.
Listen, I have an idea. I'm gonna see if Saturday 20, March 20 is good for the other sections. If the other sections would be done for a minimum of 4 lab reports, we'll go for it, okay? لأنه هن they did not start lab 3 yet. But I think until then, probably they're gonna be okay. Fine. I'm gonna try to confirm and give you a final answer next Monday. Let's not waste our time on this one. Fine. Shall we start with our new lab? Yes. Anything else hanging? I will take your silence as a yes. Okay. If you remember anything, please let me know. So I had a very good talk with my colleague who is giving the other sections. We decided not to give you lab 4 at the moment. For logistics. So you know for a fact that we cannot go on the campus yet, but probably in a week or 2 we will be able to, which means lab 4 will be given later. It's not canceled. Don't be happy with it, but I'm gonna do lab 1, 2, 3, 5 and 4 later on, okay? Fine. The thing is, I would want, and that's my plan, to record myself doing the experiment. This is the only reason. So there's no reason. The lab is easy. The physics is easy. And I'm not in a hurry to go up to lab 6. So let's do lab 5 and 4 later on. I will tell you and will update you next time I see you. So lab 5, simple harmonic motion. Ellie. So this is my favorite topic, by the way. This is the outline. What is simple harmonic motion? Some examples, implications as a Newton's second law, and then what happens to equations of motions and so on, and the period specifically, and eventually the experiment. Okay, there's a missing item that is here. Anyway, I can fix it later. Question number 1 is for you. What is simple harmonic motion? Go ahead, be loud. What is simple harmonic motion? Anyone? So what is simple harmonic motion? How do you define it? It is obviously a type of motion. Do you know any other type of motions? Anyone? All right, so Nuha said it's a periodic motion. Yes, all simple harmonic motion are periodic. All right, any other uniform motion is a different type of motion. Yes. Pendulum, probably a pendulum could be a good example, but not all types of pendulum. Some pendulums will not give you simple harmonic motion. Acts on object in equilibrium, a motion acts on object. An object at equilibrium is not in simple harmonic motion. What else? Did you study simple harmonic motion in high school?
Yes.
Actually, you did when you took the spring mass system. You did not take the pendulum unless you were doing GS, but the spring mass system oscillating back and fro around the equilibrium position was simple harmonic motion. Probably you did not call it simple harmonic motion, but I know for a fact that you did the differential equation and whatnot, right? And how did you define simple harmonic motion? In which case, if you try to remember, a motion could be given to be simple harmonic. Like for example, uniform rectilinear motion, velocity must be constant. UARM or uniformly accelerated rectilinear motion, acceleration must be constant. So simple harmonic motion, what must be what? What is the condition? You mean by resistance as in friction? Yeah, probably.
Doctor, on the same period?
Yeah, periodic, but periodic is not the most important thing. Energy must be constant, mechanical energy, I suppose. Anyway, let me start by a general definition and let me underline the most important thing. Hooke's law is very important, yes. All right, so it is a repetitive motion. In other words, we do have a constant period. But the most important thing for you to remember that the force is proportional to the distance. And I'm going to derive it for you. Okay? In general, we say that the acceleration is proportional to the position. And not only proportional to the position, it's also opposite to it. So I add a minus. If you know for UARM, uniformly accelerated rectilinear motion, the acceleration was constant, right? The acceleration was constant. Here, the acceleration is proportional to the position, and this is big, okay? These are some examples of simple harmonic motion. Do you know the tuning fork? The tuning fork, when you stuck it, it's gonna go over simple harmonic motion. So the acceleration that would govern the motion of the legs of the tuning fork will be proportional to the position with a minus sign. This spring mass system oscillating up and down around the equilibrium position will give you acceleration proportional to the position and opposite to it. Here I'm going to show you, this is a simple pendulum where the acceleration or angular acceleration will be proportional to the angle. In some cases, not in all cases. I'm going to say this is not really simple harmonic motion. I know it looks like a pendulum, but not any case of pendulum will give you simple harmonic motion. I know for a fact that you did not cover this in the course yet, right? Because look at you don't know the definitions. All right, you're gonna cover this soon in the course, which means the lab is gonna be the introduction for you, okay? I'm gonna try to remind you some stuff from high school. All right, I'm gonna start with the implications. I'm sorry for this picture is a bit blurred. I'm gonna start with net force equals MA. So Newton's second law, net force is equal to MA. The only force here, if I'm elongating the spring, is actually the tension. So I'm gonna say tension is equal to MA. If you remember Hooke's law well, tension, and let me zoom in because I need some space, just a second. What just happened? I moved one slide. Okay, so, okay, anyway, I can write here. I'm gonna simply replace tension by minus Kx. X is the position. So which means if I take this to be my 0, and this is my x-axis. When my position is positive, the tension is negative. So if the spring is elongated in this direction, meaning the position is positive, the tension is in the opposite direction. So when you elongate, when you stretch the spring, tension is to the left. In this case, when you compress the spring and position is negative, tension is gonna be positive. So I'm gonna replace T by negative Kx is equal to MA, and this will give you directly the fact that acceleration and position are proportional. Also, you have a minus sign to say if you are on the right side of the 0, your acceleration is negative. If you are on the left side of the 0, the acceleration is positive. If you cannot imagine what acceleration is, just imagine the force. It's so much easier to imagine. Acceleration and force are proportional. So, which means if you are on the right side of the 0, there is a force pulling you to the left. If you are on the left side of the 0, there is a force pulling you to the right, which means this is called a restoring force. If you go away from the center, it's gonna pull you back to the center, always opposite to your position, okay? So this is it. Now, if I need to study I'm sorry again, I'm jumping slides. If I need to study the simple pendulum, this is something probably that you did not do in high school. I'm gonna do net force is equal to MA. I'm gonna, all right, so what are the forces on my system? I have tension and I have mg. Now I'm gonna break down mg into mg cos and mg sin. And then I'm gonna say that the tension and mg cos are gonna cancel out. So the net force is gonna be mg sin. So I'm gonna say net force is equal to ma. I will say mg sin sine theta to be equal to ma. And this will not give me that acceleration is proportional to the angle unless I replace sine theta by theta. Can you please tell me in which case I replace sine theta by theta? With a minus because the mg is downward, mg sin. Yeah, in which case sine theta is equivalent to theta? Do you know?
If the
yeah, when theta is very small or when theta is less than 10 degrees. So when theta is less than 10 degrees or the equivalent in radians, you can replace sine theta by theta and then you can say the acceleration is proportional to theta. So the pendulum is not simple harmonic if you have theta greater than 10. Only when you have theta less than 10 degrees, it will be considered simple harmonic motion. And this is why I crossed out the child on the swing, because the child on the swing will be performing oscillations with an amplitude greater than 10 degrees for a fact, I suppose. All right. By the way, simple pendulum, you should have all the mass in one spot. And this is not the case for a child, where the child is big in size, by the way. All right. So as you can see, so far for simple harmonic motion, you have to show that acceleration is proportional to the position or to the angular position with a minus sign. Now we need to discuss the periods. And for me to be able to do this, I need to discuss a bit the differential equation. Didn't we say that, and I can show you here, that MA is equal to minus KX? I want to write it a bit more by saying acceleration plus K over M is equal, times X is equal to 0, okay? So I will show you this equation again. Minus Kx is equal to Ma. So you can say Ma plus Kx is equal to 0, then divide M everywhere, and you will end up with this equation. Now the acceleration is the double derivative for the position. So I can write it as X double prime plus K over M, X is equal to 0, all right? This is an equation that can be solved. You have the X, but you don't have X squared to find the roots. You have the double derivative. So this is not a polynomial function or polynomial equation to solve for X or to find the roots. This is called a differential equation. And the solution for this, for a differential equation that looks like this one, is sinusoidal. And you know for a fact that the oscillations are similar to a sine function going, it has a period, it has an amplitude, and so on. I'm not going to discuss that. I just want you to know that whatever you have here is the angular frequency. And by angular frequency, I mean, where's my blue? Okay, angular frequency, I'm going to call it W. W is 2 pi f. It's called angular frequency. And to remind you that the frequency, 1 second, the frequency is 1 over period, okay? So if you know for a fact that whatever you have here is the squared of the angular frequency, you can easily find the frequency and then the period. And this is what I get for a spring mass system. And this is what I get for a simple pendulum with an angle less than 10 degrees. So now we have equation 1, the period for a spring mass system, and equation 2 for the simple pendulum, okay? Our job is in the experiment is to study only the period of oscillation of a simple harmonic motion. We're gonna take case 1, the simple pendulum, and probably let me label this one, and this is case 2. Okay, we are not going to study the other aspects of simple harmonic motion. However, you need to know the definitions and you need to know the general behavior of a simple harmonic motion. All right. So now, do you have any questions before I proceed? All right.
Yes.
Yes, please go ahead.
Can you remind me what is the significance of the K over M?
All right, so M is the mass of the system. You see it, the one oscillating. The heavier the mass, the slower the period, because you know it's when you have a big mass, it will take you a lot of time to grab the mass and take it back to the equilibrium position. So the heavier the system, the more inertia, and the slower it would be, and the bigger the period. K is the stiffness of the spring. K has a unit of Newton, and thank you for this question, by the way, Anthony. It's a very important question. It's how stiff your spring is. I'm going to show you now different springs and different stiffness. K is big when the spring is very rigid, and K is small when the spring is very loose. Okay? When the spring is very rigid, T is going to be so the oscillation is going to be so fast and the period is going to be very small because it's a rigid spring. If the spring is loose, yani K is small, T is big, yani it's going to take a lot of time to go back to the equilibrium position. All right? So M is the mass, K is the stiffness of the spring, mass in kilograms, SI unit. In this case, L is the length of the pendulum, and you were going to measure it from the beginning of the wire to the center of gravity of your system. G is the gravitational field strength. We're going to take it to be 9.8 plus or minus 0.1 if they ever ask me to do the propagation of error. And the unit is either Newton per kilogram or meter per second squared. Okay? More questions before we move on? All right. I'm sure I missed something throughout the simple harmonic motion. Probably I can discuss it again later on. Now, the experiment. First of all, you're going to start with a pendulum, and this is what I missed, I suppose, in my outline, because in my outline, I only wrote the spring mass system. So to be honest, I should do this, and this. And this is the pendulum. This is how it should be. Okay, and this is 6. I'm going to fix it later before sending it to you. All right, so I'm going to grab a pendulum. All right. First of all, I will vary the mass. I don't have a picture showing you the mass. So the pendulum, you take a constant length. You will see in the video what ruler I've been using and what is the smallest subdivision divided by 2. The amplitude is taken to be less than 10 degrees. It's not given to you, but I'm telling you it's less than 10 degrees. And this is how we did the measurement of the amplitude. We used a regular protractor, 10 degrees or a bit like 9 degrees, and then release the oscillations. We're gonna change the mass. So mass 1, 2, 3. Number of oscillations, probably let's say 10 oscillations, and find the time for 10 oscillations. The period is time divided by 10. If they give you 5 oscillations, you do time divided by 5. So look at the number here. We usually ask the students to write the number of oscillations because sometimes if we ask them to do 10 oscillations, the pendulum will not go up to 10. It's going to stop prior, probably due to the fact that we have friction or because the amplitude is so small anyway. So we ask the students to pick the number of oscillations. And then they want us to find the average period. You will see that the period is going to be the same because the mass will not affect your period. Look here again. If you look at the pendulum, you don't have the mass component. So it's going to give you the same answer, I hope. So find the average. The uncertainty on the average is called the RMS. Then they ask you, what is your conclusion about the effect of the mass on the period? You see the mass is changing, the T is changing or not. You explain and you discuss. Compare your experimental outcome to the theoretical. How do you calculate the theoretical? You simply use the equation. T is 2 pi L over G, radical. L is given, G is given. You find T, and then you compare it with whatever is given to you. Okay? Part A, you change the mass. Part B, you will be given another table where you change the angle. Part C will be given another table where you change the length. Okay? And this is how it's gonna be done. We're gonna change the length using this ruler. Okay, it is a regular ruler. It's the same ruler I used in projectile motion, if you remember. I will be giving you one mass, so the mass is constant. The amplitude is less than 10 degrees, which means you can go back to this equation. 2 pi radical L over G. Number of oscillations, probably 5 or 10. The total time will be measured and given to you. you find the period, they want you to do t-squared because they want you to plot, if you can guess well, L or t-squared as a function of L to make it linear, if you remember we did that in data analysis. Yes, and then they would ask you the effect of length on the period. So by changing. All right, am I connected now?
How about now? Is it better?
Yes.
Yeah,
so
we can hear you now. Can you hear us?
Yes, very well. Listen, Fadi, I'm gonna put my video again. Let me know if you cannot hear me. I think my internet is okay now. Sometimes it goes out, then it comes back. If you can't hear me, I'll put it away. But let me see what happened to our Zoom recording. Just give me a second. Let me share my screen so you watch with me because I don't want, it's lagging again. Okay, I just stopped the video now. Okay. We have a problem in our router. So it is my problem, I know, but they're gonna change it this week, I hope. It's still recording, hopefully on the old recording, but don't worry, I can check and crop the video if needed. All right, so I was here, can you hear me? All right, so they discussed what happens to the change in length. You will simply look at the table and you will see changing the length will affect your period or not. Then you plot t-squared versus L, attach the graph to your report, like you know how to do that. So far, by the way, I'm impressed with everybody's lab report. Oh my God, awesome lab reports. You have awesome lab reports. And let me tell you for a fact that Physics 302 in the fall, the lab reports were really, really bad. They don't know how to type a lab report. I'm impressed with your lab report number 1. Apparently you are well trained. All right, so now let's go back. The question is find the slope. You know how to do it. The error on the slope, I think, yeah, I'm sorry, I'm lagging. Let me know if I keep on lagging, if I get disconnected. So they want you to find the error on the slope. I know that you know how to do it. Some of the students are still having difficulties. So this is your second chance to practice. They want you to deduce G from the slope. Look at the equation well. T-squared versus L. What would be the slope? So write the equation T-squared versus L. What would be the slope? It will be something 4 pi squared something. And then you're gonna find G from the slope. So be careful when they say deduce G, it means from the slope. All right? Show your calculations. So you're gonna ask me, are we supposed to type everything? Just skip some steps, but yes, explain what you did. And then they want you to compare with the theoretical value. So you do the percentage error. And this is just a random question to answer as well. All right. I'm sorry, I'm going fast. I'm just scared I'm gonna lose you soon, but I can go and repeat if you have any question. Let me put the chats on. Yes, so I can keep on reading you. I'm still lagging, I hope not. All right, so now we're gonna put a vertical spring. This is the springs are, you have a box of springs. We're gonna pick one randomly. Each spring has a different K, by the way. In this case, L is the difference in height. No, you mean, all right, we've been doing, Fadi, be careful, we've been doing the pendulum. And L for the pendulum is the length of the wire up to the center of gravity of your pendulum bob. For the spring mass system, this case, we're not gonna take the length. We're gonna only vary the mass and measure the period. Change the mass, measure the period. Change the mass, measure the period. And we're gonna do 1, 2, 3, 4 trials and to find the average. So we're repeating exactly the same experiment. No change in length. We're not finding the stretching, neither the elongation. Okay, so for the spring mass system, we only vary the mass. In the past, we varied K, not anymore. So you're gonna do all the experiment on only one spring. Change the mass. For the pendulum, you change the length and the mass and the amplitude. For the spring, only the mass, and you're gonna do only mass 1, 2, 3, and that's it. Okay? As you can see, this is Dr. Summer doing the experiment and not me, because she taught this course in the fall, and nobody else taught this course in the fall, and we are not allowed to go to the campus. So I'm gonna share with you her video of the experiment that I find very interesting. By the way, I have it open and I took screenshots from her video. I'm not gonna play it, neither fast forward, neither anything, because I don't have a downloaded copy of it. But you will see that she divided it into chapters. I know it's a bit long, 21 minutes, but she has a very small theoretical part that I urge you to watch because it will complement your PowerPoint. So the PowerPoint may tackle an aspect of simple harmonic motion, and probably her theoretical part will tackle the same or a different part of the theory, okay? And then she's gonna show you the experiment. I think it's nice to watch with a drink or something, so don't, it's not something heavy to watch and take notes, okay? So go over it, let me know, I would want to see your feedback. For lab number 4, we don't have neither a video from Ms. Summer, neither a video from Ms. Jessie, so that's why we postponed lab 4 for the moment. I think we can go on campus next week, but let me check and we'll let you know. That's it. We went a bit fast over some aspects.
Dr. فيني معك؟
Yes, I can hear you. بدك تروحي معي؟
فيني أروح معك on campus؟
You wanna go? By the way, did you ever visit the campus?
دكتور أنا آخر مرة داعس الكامبس هو من 3 سنين بالأميوان، غير هيك مش داعس الكامبس.
This is so sad. You know, I've been in LAU since 2006. You know what it means since 2006? Yani, the physics lab is my office. I used to sleep there. I used to shower on campus. I have my food, the fridge, the microwave, the people. And I used to sit there up to 8 p.m. So can you imagine what I missed? The last time I went to campus, I actually went on several occasions in the fall to record experiments. It was sad because I couldn't sit in one room with another person. You know, we need to talk to the lab supervisor and do the work. She used to prepare the equipment and leave. Can you imagine? I tried to get students to the campus in the fall because we were allowed to do so under specific conditions. But it was so tough on me that I decided not to go anymore, not to ask the students to come. So, you know, listen, don't be sad. Think of every opportunity to be for your best at some point. Probably you're more efficient right now. And probably you're gonna go later to the campus, hopefully soon. All right? Probably if you are on campus, you would be more stressed. Probably you can take more courses while you're more focused with less commuting. I don't know. How about you focus on the positive things, not the negative things? All right? I will also, okay, I'm gonna stop recording because I don't want people who are offline to suffer from us